right, guys. Everybody have a note sheet. We are starting chapter 3. Today. Now, chapter 3 is going to be revolving around quadratics, our parabolas, but in a little different way. We're going to be looking at more of the properties, solving, doing a little bit more with them than talking about their graphs. We will still talk about the graphs a little bit, but more in terms of solving than anything else. Also, all of y'all's tests, except for yours, has been posted in Google Classroom because it's chapter 2 tests. MUP, makeup points, because again, talked at the beginning of the year, you can do makeup points. And again, you can just schedule a time to talk with me. We'll get you time to come in and do the makeup points. Makeup points, you go back and correct the ones you got wrong, the points that you lost, and you can earn that back half those points. All you've got to do is go back and correct them. You can use any resource at your disposal to correct them. Textbook. You can ask me questions, but go back and correct them. To get earned back half the points. And I put it in the makeup point section because, again, that's where I put it just to separate the two. Again, if your question's on zeros, I would look first at how many points it's out of. 0 out of 0 does not hurt your grade. If points go in there, it actually helps it more than anything else. All right. And the test average have did better than they have in the past few years. So y'all did quite well on that test. Now, what we're going to be starting out with 3.1 is factoring. Y'all done the opposite of factoring, this distributed property before. Y'all done these here. Because if we look at the first one, 4x minus 5 times x minus 3, we would distribute. We start out with multiplying through by the 4x. So we'd have 4x times x, which is 4x squared, because we'll multiply the 4 and the number. With 4x and x, we'd multiply the numbers in front of them first. Well, that'd be 4 times 1, which is 4. X times x is x squared. The next thing we do is 4x times negative 3. 4 times negative 3 is negative 12. And we still have our x. 4x times negative 3x would be negative 12x. Our next step would be to do negative 5 times x, which would be negative 5x. And lastly, negative 5 times negative 3. Negative times a negative is a positive, and 3 times 5 is 15. And then we'll need to combine like terms. Questions on this so far? Okay. Last thing we need to do is combine like terms. Only like terms we have are negative 12x and negative 5x. 4x squared does not have any like terms. Our negative 12x, negative 5x, negative 12 minus 5 would be negative 17x plus 15. That's all we're due for that one there. We're just multiplying it out. Yes, so all of these here are considered or called quadratics. Standard form are ax squared plus bx plus c. Let's look at the other one. Guys. 4x times x would be 4x squared. 4x times negative 4, because negative 4 times 4 is going to be negative 16. And then we'd still have our x. So okay. Yeah.
Okay, you can go back.
Okay. So our next one would be what over here? Negative 4 times x, negative 4x. Negative 4 times negative 4, the negative times the negative makes it positive, and 4 times 4 is 16. Then we combine like terms. Negative 16 minus negative 4, negative 16 minus 4x. 4x squared minus 20x plus 16. So this is distributive, multiplying them out. Because what we're going to be doing with this here in 3.1 is factoring. So we're not going to be given it in two sets of parentheses. Because these here, I want a highlighter. This form here and this form here are what we call factored form. They are factored. So what we're going to be given, the quadratic, is in standard form, our ax squared plus bx plus c, and we want to get it back to factored form, our two sets of parentheses. So I'm not going to worry about the ax squared plus, or ax plus b, or a plus b times a plus b. We're going to move on to this next part here. Previously, you factored polynomials of the form ax squared plus bx plus c, where a is equal to 1. What they're talking about is Algebra 1. The last part of Algebra 1, or some of the last chapters, is going over factoring. To factor polynomials of the form ax squared plus bx plus c, we have several steps. And the first is looking for a greatest common factor. Sometimes it's nice to have steps. The first main step in factoring, especially these quadratics in the form of ax squared plus bx plus c, is to find the greatest common factor. So the first thing we really need to be looking for is a number or term, number or variable that is common in all three, common throughout the expression. If there is, we want to factor it out. We want to remove it, because if there is a greatest common factor, removing it will help make solving the problem, factoring, a lot nicer, because it will reduce some of the numbers. So we're not looking at as many factors, as many terms, if it's in common with all three. Our second step, we're going to write two sets of parentheses with three spaces. Okay. All right, guys. Focus up here. So these are our first two steps. We'll get to step number 3 in a minute. So we have this right here, yes? So it's asking to factor this. So if we look at this here, we want to factor 5x squared plus 15x plus 10. Our first step is to see if there's a greatest common factor. Is there a number or variable in common with 5x squared, 15x, and 10? 5 will go into 5, 15, and 10, yes? So the first step in factoring is to factor a 5 out. There is no variable in common with all three, because we do have x squared in the first, we have x in the middle, but we don't have a variable in the third term. It's not in common with all three. So we're going to factor a 5 out. And when we factor a 5 out, or factoring a term out, really we're dividing each term in the expression by that amount. So really what we're doing is dividing each term by 5. So if we divide 5x squared by 5, the 5 divided by 5 becomes 1x squared, or just x squared. Plus, because we're not applying a negative to it, or factoring out a sign, we'll divide the next one by 5. 15x divided by 5. 15 divided by 5 is 3x. 10 divided by 5 is 2. So instead of working with 5x squared plus 15x plus 10, we're now mainly focused on factoring x squared plus 3x plus 2. Factoring out those greatest common factors helps make factoring a little bit easier. Questions on step number 1? Okay. Step number 2. We're going to write 2 sets of parentheses with 3 spaces. We still have the 5. We have to keep this greatest common factor with us through this whole process. But our next main step is to write 2 sets of parentheses with 3 spaces. Now, part of the reason we do 3 spaces is to make sure we have enough room. Because when we factor this, we're going to have 4 terms. 2 are going to go in each one, and there's going to be a sign in the middle. So the middle spot in both of these parentheses will be a sign, either plus or minus, one of the two. Now that brings us to step number 3. Now there are different ways to factor. I feel like finding the signs is the next nice step, because in doing so, we're not having to focus on the factors with signs being positive, negative in all the cases, because that removes it. We're just looking at the factors. Now, finding the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is positive, the signs are the same and match the sign of the middle term. Well, so I feel like step 3, part A makes some sense, but doesn't make sense at the same. It seems a little weird. Because if the third term could be positive, but also the third term could be negative. If the third term is negative, the signs are opposite. All that means, if the third term is negative, the signs are opposite. One of them is going to be positive, one of them is going to be negative. One's going to be plus, one's going to be minus. That's it. If the third term is positive, the signs are the same and match the sign of the middle term. So if the third term is positive, we look at the middle. If the middle is negative, they're both negative. If the middle term is positive, they're both going to be positive. So let's look at the example we have here. So the third term sign is what we're looking for. Not so much the number, the sign. Here the third term is plus 2. Positive 2, yes? Since the third term is positive, the signs are the same and match the sign of the middle term, which is also positive 3, positive. Which means our signs are the same and both positive. If it had been minus 3x in the middle and our plus 2, the signs would be the same and they would both have been negative. Questions on this step here? Since the third term was positive, the signs are the same and match the sign of the middle term. So it's plus and plus. Questions on this here? Okay. Step number 4. Find the factors of the first and third terms. Let's go on and put the last step up. Step number 5, plug in and check. So step 4, find the factors of the first and third term. Once we get those factors, we're going to plug them in and check them. We're going to plug them in and check them to make sure that we do have the correct factors. So, factors of the first and third term. Our first term is going to be that x squared term. Our third term here is 2. So let's look at the factors of x squared first, our first term. So we're looking for what multiplies together to give us x squared. X times x. That's the only set of factors that we'll have. We do have 1 in x squared, but that doesn't help us here. X and x. Questions on this here? Now we also need to find the factors of the third term, factors of 2. What numbers multiply together to give us 2? And 1 times 2. We only have 1 set of factors for each. And really, if we only have 1 set of factors, we're just going to go on and plug them in because there's no other factors it could be. So we're going to plug these in. So for the first term, since it's x squared, it's going to be plugged in the first spot of each of the parentheses. Factors of the first term go in the first spots. Factors of the third term go in the third spots. And it doesn't matter too much which ones we put them in because we actually already started step 5, plug it in and check. Because once we get them plugged in, we're going to check. So I'm going to pause for a second before we start checking. Questions on any of this here so far? We won't need that 5. So we only need it once. We just need it in the front. We're ready to check. Okay. Now, textbooks, most textbooks, and the mathematical way to check is to multiply this all the way back out to see do we get back where we started. Or here, multiply our x plus 1 and x plus 2 together to see do we get back to x squared plus 3x plus 2. Now, personally, I don't see a whole lot of reason for that, because x times x is x squared. Well, where did we get x and x from? The factors of x squared. So they should multiply back together to be x squared. I'm not concerned about that. Or doing 1 times 2, because 1 times 2 is 2. 2, because where did we get 1 and 2 from? The factors of 2. The main one we're checking for is the middle term. The middle term, the 3x. And where we get the 3x from is our x times 2 and 1 times x. These are the ones I check. Question? Okay. Because our 2 times x would be 2x. Our 1 times x is plus x. And 2x plus x is 3x. Is that the middle term that we have? Yes. If those match up, then this here is the correct factorization. Questions on this here so far? We ready for the next one? Okay. Let's look at this next one here. 4x squared plus 32x plus 60. Again, we should always be looking for a greatest common factor, a number or term that is common in every spot. Is there a number or term that goes into 4x squared, 32x, and 60? 4. And really what we're going to be doing here when we factor greatest common factor out is we're dividing every term by that amount. So we're going to divide all 3 terms by 4. Our 4x squared divided by 4 is x squared. Well, we'll be going through them multiple times. Yes, 32x divided by 4 is going to be 8x, plus 60 divided by 4 is 20 would be 3. Or 15, thank you. If I don't watch it, I write the wrong thing. Questions on step 1 using the greatest common factor. Step number 2. 2 sets of parentheses with 3 spaces. So we'll still need the greatest common factor. The greatest common factor of 4 is a part of our final answer. We have to keep it with us. So, yes. Questions on steps 1 or 2? So we did greatest common factor, then we wrote 2 sets of parentheses with 3 spaces. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So the third term is positive. So the signs are the same, and they match the sign of the middle term, which is also positive. Positive and positive. Questions on steps 1, 2, or 3? All right, guys. All right, guys. Questions on the 1, 2, or 3? Steps 1, 2, 3. Step number 4, find the factors of the first and third terms. So our first term is x squared. Well, the factors of x squared are x times x. So factors of 15. We have 1 and 15. Is 2 a factor? No, 2 is not a factor of 15, but and 3 and 5. So here I'm just listing all the factors out.
Oh, you gotta figure out which factors are that.
Yes. So now we'll focus on 15 here in a second. Factors of x squared were just what? X and there's only one set of factors, yes? There's one set of factors. We'll go on in, plug it in, because those have to be the factors for x squared, x and x. Now the question is, factors of 15, 1 and 15 or 3 and 5. Now we'll do 3. 3 and 5. 3 and 5 does give us 8. Now the last step, that check, this is why the check's important, because it does check it to make sure they are indeed the correct factors. Again, like I said with the last one, I'm not so focused on the x times x, because x times x is still x squared, yes? 3 times 5 is still 15, because we got both of those from the factors of x squared and the factors of 15. The main ones I want to check are x times 5 and 3 times x, because x times 5 is 5x, positive 5x. 3 times x is positive 3x, so plus 3x. And 5x plus 3x is positive 8x. Is that the same as our middle term we started with? So that tells us 4 times x plus 3 times x plus 5 is the correct factorization for our 4x squared plus 32x plus 60. Questions on this here? Questions on this here? Questions on this so far? Now, if we did 1 and 15, we would get a different answer. So if we check this here, x times 15 is 15x. 1 times x is plus x, giving us 16x, which is not the same as 8x. So those would not be the correct factors if we did 1 and 15. But x times x is still x squared. 1 times 15 is still 15. Those still work. But by changing that, we change the middle term. And really, that's the only thing that changed. That's why I focus on the middle term, not the first or third when checking. The first and third should stay the same. Middle's the one that's changing. Questions on this so far? We ready for the next one? So our next one, yeah. Okay. No, you're good. Four x squared plus 13x plus 3. Step number 1 is find the greatest common factor, yes? So the greatest common factor between these 3 terms is 4, yes? Well, no, right? 4 is not divisible by 4x squared, 13x, and 3. is there a number that goes into all three terms? 1. I can factor 1 out. If we do, it changes 4x squared to 4x squared. It changes 13x to 13x and 3 to 3. It doesn't do anything. So, is there a greatest common factor? No. There's not always going to be one. If there is one, it is nice to factor it out, to simplify it out first. If there's not one, well, we go from step number 1 to step number 2. And our second step is 2 sets of parentheses with 3 spaces. Because if there is no greatest common factor, we just move to step number 2. You're welcome. Okay. Questions on this one so far? So that brings us to step number 3. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. And yes, I'm going to be repeating that multiple times. So when we look at this here, our third term is 3, but it is positive 3. So the third term is positive. So the signs are the same and match the sign of the middle term. And the middle term is also positive. So we'll have plus and plus. When finding the signs, the only time we focus on the sign of the middle term is if the third term is positive. If the third term is negative, they're automatically opposite. One's positive, one's negative. It doesn't matter which one. And it really doesn't matter how we set this up. We need to get it set up because part of step number 5 is to check. We're going to check and make sure we got it right. If we didn't, we're going to fix it. We're going to try different factors. So we have the steps 1, 2, and 3. Now we're going to look at step number 4, the factors of the first and third term. Now the factors of the first term, we have 4x squared. So we'd have 4x, so x times 4x. I like to put the smaller one first. So 1x times 4x. Then we'd have 2x times 2x. Wait a minute. With this here, no matter what the factors for any of them are, our x squared is what? X and x, yes? There's no other way that that works. X and x is always going to be with that. Since the x squared's in the first term, really, I can say we have x and x. If the x squared's in the third term, we can just put the x and x in the third spot. That's the only set of factors for it. That's the only way we can have x squared and be able to factor. Does that make sense? So really what we're looking at with our first term is not really 4x squared, but the factors of 4, which is 1 and 4 or 2 and 2. Since we know x squared has to be x and x, we throw it in. We're really looking at the factors of 4. Only pick one, 1 and 4 or 2 and 2? 2 and 2. Now, let's look at the factors of the third term. Factors of 3. What are our factors of 3? 1 and 3. That's it. It's prime. There's only one set of factors. I mean, if we start going with irrational numbers, there are more factors, but that's not going to help us here. So that gets us through steps 1 through 4 and part of 5. We're starting to plug them in. And the last part is to check. Now the main thing we check is our 2x times 3 and 1 times 2x. Because our 2x times 2x is still 4x squared. Our 1 times 3 is still 3. Now 2x times 3, 2x times positive 3, is positive 6x. 1 times 2x is plus 2x, giving us 8x. Positive 8x. Is positive 8x our middle term? No. Some. I would say so, because I mean the first thing we can do is switch the 1 and 3. Is that going to do anything? No, because it's still 2 and 2. The first term's the same. Now we can switch the 2 and 2 for 1 and 4. Where do y'all want to place the 1 and where do you want to place the 4? 4 in the first, 1 in the second. And we can check this again. 4x times 3, 4 times 3 is positive 12x. 1 times x is plus x, and 12x plus x gives us positive 13x. Is that the middle term we wanted? So 4x plus 1 times x plus 3 are the correct factors. And part of the thing that most students dislike with factoring, it's a lot of guess and check. We plug it in, we try it. If it is the correct middle term, we have it factored. If not, we try it again. And the more of these that y'all do, the more of these that you factor, you'll start seeing patterns that emerge from them and start seeing which factors are more likely going to work than others. Questions on this so far? Let's look at this one here. 3x squared minus 7x plus 2. There is no greatest common factor between 3x squared, 7x, and 2. One kind of main way is 3 and 2 are both prime. They're not, and they don't have anything in common. So since there is no greatest common factor, we go to step number 2. Our 2 sets of parentheses with 3 spaces. Now again, I put the spaces there to kind of more help ourselves in making sure that we don't put them too close together. We have enough room for everything to fit. That's the only reason for that. Bless you. Questions on this so far? We feel good with this so far. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So here, the third term is positive. So the signs are the same and match the sign of the middle term. And our middle term this time is negative. So the signs are both negative. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. And there's a logic behind this. Because to get this third term, we're having to multiply the numbers in the third spot together. Yes? Because that's how we get that constant term, that term without a variable. Now positive, if we're multiplying 2 numbers together and get a positive, they're either A, both positive, or both negative. Because a positive times a positive is a positive. A negative times a negative is a negative. Our middle terms, we combine. We add them together. So the only way I can multiply, so our middle term's negative. The only way I can add 2 numbers together and get a negative and multiply them together to be a positive is if they're both negative. Questions on this so far? We kind of get why this is negative and negative, yes? Factors of the first and third term. So the factors of the first term. Factors, we're looking at 3x squared. Well, x squared is just what?
Yeah, you're right, x.
Because x and x, that's the only factors for x squared, since it shows up in the first spot, our first set of first terms factors. Only one set, x and x. We'll throw them in. Now we're looking, the factors are 3 or 1 and 3, yes? We can go on and throw those in, because there's only one of them. We'll put them in there. Where do we want to put the 1 and where do we want to put the 3?
So, do 1 first, maybe.
1 first, 3 seconds. We can write 1x or we can leave it as x. Those are the same. Questions on this so far? Factors of 2 are 1 and 2. There's only one set, yes? Where do we want to put the 1 and where do we want to put the 2? 2 first, 1 second. And again, the way that we order this really doesn't matter at this point. We need to stick them in there. Stick those factors in because our last part is to check. Now again, I'm not checking x times 3x because x times 3x is 3x squared. That's the factors of 3x squared. So the only ones I really want to check is x and negative 1. X times negative 1 is negative x. Negative 2 times 3x. Negative 2 times 3 is negative x. Questions on this so far? Negative x minus 6x. Because negative x minus 6x is the same as negative 1 minus 6. Negative 1 minus 6 is negative 7. We can't plug the x into the calculator, but we can subtract the coefficients, the numbers in front of them, or combine two numbers in front of them. Is negative 7x the middle term we wanted? So x minus 2 times 3x minus 1 are the correct factors for this here. Questions on this so far? We'll leave the last two for tomorrow.